Um, Hi, everybody. My name is Xiaohan Bao Smith. I'm the Historic Properties Coordinator of MHPN, Michigan Historic Preservation Network. And we are very excited today to have Kelly Streeter from Vertical Access to talk about designing maintenance access and fall protection for inspection. And before we get started, I would like to go over a few items. If you have any questions, please type them into the Q&A box as you think of them, and questions will be answered at the end of the presentation. And please feel free to use the chat box to share your thoughts and resources. And both the chat box and Q&A box are located at the bottom of your Zoom screen. If you don't see them, please wiggle your mouse. And after the webinar concludes, please help us improve our webinars by participating in the survey. If this is your first time attending our webinar, we are the Michigan Historic Preservation Network. We advocate for Michigan's historic places to contribute to our economic vitality, sense of place, and connection to the past. We could not do the work we do without our members and volunteers. If you are not a member yet, please consider joining us at www.mhpn.org. This webinar is supported in part by an award from the Michigan Arts and Cultural Council. And it is my great pleasure today to introduce our speaker, Kelly. Kelly Streeter, PE, is a Vertical Access partner. She leads the company's investigation teams and the development of inspection technologies. She also lectures at Historic Preservation University programs. Kelly received her master's in structural engineering from the University of Colorado and her bachelor's of science in structural engineering from Cornell University. She is a registered professional engineer and a Society of Professional Rope Access Technicians, Level 3 Rope Access Supervisor. And with that, I will go ahead and turn it over to Kelly.
Thank you, Sean. Let's see. Oh, push the wrong button. Go. Okay. Hopefully everyone can see my title screen. Okay. Thank you for that introduction, and thank you for having me and setting this up. We've already done the introduction, and now it's not. Hold on, it's not advancing. Yep, there it goes. Okay. A little bit about sort of vertical access for those of you. We do a little bit of work in Michigan and Detroit specifically, but for those of you who don't know what we do, we are usually act as sub-consultants in the discovery phase of restoration projects. So that can involve any discovery tasks, including non-destructive evaluation, which is kind of my passion, gauge installation. We have a fleet of drones. We are really right now advancing our laser scanning and photogrammetry capabilities. And in all cases, we are doing hands-on assessment. Sometimes we get into probes, and then as an outgrowth of that sort of base business, we have really become experts, much to our surprise, in fall protection, and that includes on the construction side, the installation of temporary stabilization measures. First, a little bit of an overview about what we're going to talk about today. I'm going to walk you through this bulleted list. The introduction, what do we mean when we say MAFP? So MAFP is maintenance, access, and fall protection. So we will get into, towards the end of the presentation, some really, really cool case studies. So I just ask that while we're in sort of the regulatory, when I'm talking with a bunch of acronyms, hang in there, because the end of the presentation is a lot more dynamic. So why do we think this is important? And why have we created sort of a series of presentations specifically about MAFP? So working on buildings is dangerous. And unfortunately, even with the advance in recent years with Zoom and all these different ways we can communicate and train and learn and share information, we've had sort of a spotty kind of up and down roller coaster of falls to a lower level that result in days away from work. And surprisingly enough, if you had asked me a few years ago what industry is the biggest culprit or the biggest location where we see these falls, it's not construction. Construction's only 29%, and service providing industries is a whopping 59%. And upon reflection, that kind of makes sense because there's a lot more required training, OSHA 30, OSHA 10, in the construction industry than there are in sort of more disparate and disorganized service providing industries. So this is the drier part, but to give you some historical background, in 1977, Congress passed what's called the OSHA General Duty Clause. And so there's two parts to that, and everyone really concentrates on the first one because we're also concerned with liability. The first part, part A, is that each employer has to furnish to his employees a place of employment which are free from recognized hazards, et cetera, et cetera, et cetera. The second part is the employee must comply with any occupational safety and health standards and all rules that are promulgated by their employer. And just to be very clear, when we're talking about these typical maintenance activities, we're talking about activities that are performed by employees, not by outside contractors. So there's a bit of a distinction there, and a lot of the questions are usually about that distinction. But if a maintenance employee works for the building or works for that company, it is beholden to that company to follow OSHA's General Duty Clause. So the basics, there's two parts of MAFP. There's the A, the access, which is work positioning. It's what gets you to your work location. And then there's fall protection, which is what makes sure that you don't fall once you're there. And we'll go into, there's many different types of work positioning and fall protection. Every third slide, it's not wanting to, oh, there we go. Okay, so I really like this image. I've used it for a long time. I lost it for a while, but was excited to refind it because it really makes sense. So we want to start on the left. The best thing that we can do from a problem-solving perspective is eliminate the hazard if possible. The second best thing is provide a passive means of fall protection. And, we're talking pretty much about railing systems. Number 3 is fall restraint. So the guy with the orange harness is on a tether or a lanyard that is designed such that he or cannot get to that edge, cannot expose him or herself to the fall. Number 4 is a fall arrest system. So if the work that's required kind of by nature will expose someone to a fall arrest system will stop that person. They might fall over the edge, but they won't fall to the ground or to the lower level. And the least advantageous method is administrative controls. And it's the least preferred because it relies on work practices or procedures that are supposed to increase a worker's awareness of fall hazards and how to work to avoid them. And the problem with that, which I will harp on all presentation, is that employee continuity and employee training. That is assuming that those training modules are rigorously followed, and that, say Joe's out sick and Ben is in, and Ben, doesn't know the administrative controls. So we really, if at all possible, start with one, and then, at each phase we say, okay, well, maybe we can't do 2, maybe we can do 3. So we always try to stay closer to that green zone when we're addressing a problem. So work positioning can take many forms. What you're seeing here is an MAFP system. The access is the ladder, and the fall protection is twofold. There's a track in the chimney, and then there's also a horizontal lifeline at the base of the gutter. It might be my internet, but it's being very slow. Here we go. Then we have lift truck, which can provide both the access and the fall protection. This is definitely further to the left in that hierarchy. It's a very safe way to work if someone is trained. And then you have everything in between. You have incredibly complex custom building maintenance units like this one. At Vertical Access, we see a lot of these on rooftops, and the typical issue with these is that they're not maintained. There's not really a chain of custody and operations manual, certification, et cetera. And so they're usually just hulking, rusted beams nobody knows how to use. And so we end up on a lot of these buildings using industrial rope access instead. So when do we want to think about MAFP? I would say the second there's a project. If there's a project that involves the restoration of a roof, or if you're building a new building that obviously has a roof and there are going to be things that need to be accessed, the earlier that we can think about it, the better. This specification right here is actually from a project. And the entire project was coordinated to within an inch of its life. And then I get this spec that the system description is: the work positioning and fall protection system shall allow a qualified user to safely access gutters on the building. It should allow the trained user to safely access the gutter by movable ladders and provides fall protection while the gutter is being serviced. All components shall be included, even if not mentioned in this specification. So there were 0 drawings. There was specific to MAFP. There was 1 note pointing to the gutter saying provide a maintenance access and fall protection system, and this specification. So no cost estimator is going to know what on earth this is. So what typically happens is a contractor will just make a number up and then treat this little section of the project as a delegated design project. So they usually then reach out to an engineer or a contractor, and typically their cost estimate is not appropriate, and then you have a pretty upset owner. So the goal, as in every other part of a fully designed project, is to have specifications that are coordinated with roofing, with structural, et cetera, so that all the cost estimates actually reflect reality. So this is where it gets a little bit dry, but keep your eye on the prize. Those case studies are coming. So fall protection and overall workplace safety is covered by the Occupational Safety and Health Administration. And general building maintenance falls under the general industry category, which is 1910. So don't get confused. 1926 is construction. 1910 is everything that's not construction. And then there's this other one that's all by itself, and that's for anything that can be considered marine construction. So what we're talking about really is 1910. OSHA really likes the word shall. They will tell you that you shall do this and you shall do that. And then they leave a big hole because they don't really tell any engineers or stakeholders how to comply with their mandates. So this is one of my favorite ones. For these and other reasons, the design of systems using horizontal lifelines must only be done by qualified persons. Testing of installed lifelines and anchors prior to use is recommended. Do you know how to design and install a horizontal lifeline with that great amount of information? No. So where OSHA kind of has all of these shall statements that are sort of sprinkled throughout 1910. So subpart D, F, and I, all 3 of those have different references to work positioning and fall protection. They don't really tell you how to test, how to design. They sort of just go, you better do it. So then where they leave that vacuum, ANSI, the American National Standards Institute, has stepped into that void. And that there's a group of, I think it's probably 170 of us now, engineers, product manufacturers, and end users who all get together twice a year and argue about how to actually design different work positioning and fall protection systems. And that is called ANSI Z359, or the Fall Protection Code. It's, I should have had it off my shelf. It's about, if you print it out, it's about this thick at this point. So, and it's very technical. So you do really need somebody who's kind of gotten into it and had to figure out how to use it, how to interact, sort of best practices from International Building Code and structural engineering practices with what the Fall Protection Code says. And if you just Google Z359, you will find a million white papers and articles, many of them by fall protection manufacturers on Z359. Lots of information. So who does the design then? And this is kind of an interesting one. The manufacturers, the large manufacturers especially, of different types of systems like vertical lifelines and horizontal lifelines and rigid rails, et cetera, usually have an engineering or a design arm, okay? And so that's their loss leader. If they provide that service to an architect, give them a specification and a drawing, et cetera, they know that you're going to end up using their systems. You're going to use Honeywell over Latchways, or Latchways over Spanco, or what have you. So just know that if you want to use a manufacturer, you're going to get a spec for their system, obviously. Sometimes architects will will get involved, or at least involved initially, and then maybe reach out to the engineer of record. Most often the engineer of record says, no, thank you. My insurance would freak out if I did anything that had to do with the words fall protection from a liability perspective. Building owners and managers sometimes do get involved with sort of designing and installing systems. And then sometimes it's, those people who are actually doing the work, those maintenance personnel who are advocating for themselves to have a safe workplace. So we're going to go through the different process, start to finish, of an MAFP system. So as I said before, the access is work positioning. Could be movable ladders, it could be ropes. Sometimes you don't really need one and you're just standing on your feet if you're on a flat roof. And then the different fall protection components, horizontal lifeline, discrete fall protection anchors, et cetera. So think about it as you've got you've got a problem solving issue. Okay, so you have to figure out the work positioning, and depending on the solution for the work positioning, then we go to that hierarchy of controls about how to deal with fall protection. So ideally it's designed, it's completely thoroughly designed. So these are the manufactured components of, say, in this case, a horizontal lifeline system with part numbers, et cetera. This is the load diagrams that we hand over to the engineer of record. So, basically from the roof surface or roof sheathing up is the MAFP designer. And then from the roof system down is the structural engineer of record, has to make sure that the building and the substructure can withstand these loads. And then there is how the manufactured system is actually attached to the substrate. Sorry, that was a little fast. And you'll see this, this is a drawing from one of our case studies, and I'll show you this later. And you can see it's not concrete. This is terracotta book tile. And this is where, to me, it gets really interesting, is how do we put these sort of new modern systems that require a lot of structural capacity. How do we figure out how to develop that structural capacity in historic materials? And then using the system, and this, when I say I'm going to harp on training and expertise, this is where the ball is dropped. Okay, so you can have the most robust and theoretically safe system, but if you don't maintain it, and if you don't train your employees and retrain and retrain and retrain your employees, someone can still get hurt. Someone can misuse the system, and accidents can happen simply because the third-party certification, hardware inspection, recertification, and in-house training policies were not robust. I also always advocate for not just speccing out those items that are permanently installed on the structure, like the anchor and the horizontal lifeline and all that, but the PPE or personal protective equipment that interacts, basically allows an end user to interact with the system. So the basis for design for all of these systems is that whatever is designed has to limit the force on a falling body to 900 pounds force. So you can have a system that does it, but if you have the wrong lanyard, if you have the wrong self-retracting lanyard, if you have the wrong shock absorber, then you can violate that rule. So this is part of the design and part of the specification. Now for the fun part, I've got four, I think, case studies. So we're going to start with a historic public building in Manhattan. A lot of roof area. So a really low sloped roof with a gutter area that needed to be accessed. And a series of hatches for getting out there, but no way when we arrived on site to protect somebody falling over the edge. So this was one of those, the architect said, oh, well, we did something similar over here at this other building that kind of looks the same. So it was a complete cut and paste job, unfortunately. And you'll see why the appropriate attention really wasn't paid to the constructability of these details at this site. So the pictures, the photos here are of the installation on that other building. And this is at that other building. So they actually did sandwich plates to engage the book tile and the entire, roof system. And then these giant turnbuckles were welded back to the steel in the attic. We couldn't do that in our case. And yeah, it looks good. It looks sleek. It kind of, blends in with the snow guard system beyond. But our challenge at our building was that this was what we would be working over. So this is the ceiling, one of the major ceilings in one of those areas. And there were several very, very amazing murals. Any Manhattan tourist people will know what building I'm talking about. So we had that issue that we didn't want to be welding and carrying things over these beautiful murals. And also we had to deal with MAFP even in the attic. We had some double height spaces. The eaves were very, very difficult to get to. I was not going to weld in this space. It would have been an absolute nightmare. So we got creative. We did a series of empirical research probes and testing. So we tested a lot of Hilti HY70 anchors in book tile. So we did pull tests to failure in many different locations, and then design plates. And the plates did have to be larger. The corner plates especially had to be quite large. But this was considered a more acceptable solution than having to penetrate the roof and figure out how to weld in these very, very tricky spaces. And in the end, yes, those plates are big. You can't really see them because the low slope, and unlike the other project, we tucked the horizontal lifeline behind the snow guard. So really what you see is the snow guard, not the horizontal lifeline. Also, it's not like, okay, we're doing HLLs everywhere. So at the courtyard locations, we just said, let's keep the railings, and the Landmarks Conservancy was fine with that. And so we kept, that number 2 on the hierarchy, that passive system at the courtyards. And there's really no visual impact whatsoever. I mean, every time I'm going to New York later today, and every time I walk by, kind of squinting or taking a picture on my phone and zooming in, and you really, really can't see it at all. Case study 2 is a historic building in Brooklyn, New York. It was originally built in 1892, a granite clad portion, and then in 1933, an addition was added that is terracotta clad. But in all cases, the roofs are these steep mansard roofs with these gutters that span between these engaged dormers. And when we did our condition assessment here, these gutters were filled with bird carcasses and plastic bags and leaf litter and absolutely overflowing with water. So this was before the complete exterior restoration. So you can see that the roof has kind of been repaired in certain areas. What they didn't want to have to do was basically hire a rope access contractor to go down and clear out the gutters, 4 times a year. So we started the conversation with all of the stakeholders of sort of the different ways that we thought we could safely train the existing staff to get down there. I advocated for the use of a lift truck, a boom truck, but the first floor is occupied by the U.S. Postal Service, so it's pretty much impossible to close the streets. So different ground conditions like landscape and getting DOT street closure permits can really limit the safer options as well. So this is what we came up with. It is a custom rolling ladder system that, once it's completely in place, does not bear on the slate. So it pops up onto, at the bottom, I think you can see it, it pops up onto the snow guardrail at the bottom. So we worked with the snow guardrail manufacturer to make sure that it could withstand that load. And these are all the different places the ladders could be. There's actually only 1 ladder, or maybe 2, but it gives you an idea of the 10 different places on this elevation where we can deploy this ladder system. Sorry about that. Okay. And so this is it in practice. This is during one of the training sessions, making sure everyone understood that they had to be on fall protection. You see this guy is on fall protection here, that it takes 2 people, that there's a line basically saying you can't go past this line until you're on fall protection. And then there is a vertical lifeline for when they're actually going down the ladder and clearing out the gutters. Case study 3 is a historic conservatory in the Bronx. I learned a lot on this one. I learned a lot about the very unique structural and construction details of conservatories. It's very, very challenging to access, obviously, because of the shape and the materials. So we went with something incredibly simple, and simple, but further to the right on that hierarchy. And that is because I have a level of trust with the powers that be at this institution. They understand that we are very serious about the training, and I go back there every 18 months and we have a refresher. We've done videos and very complete drawings about how to use the system. There is a horizontal lifeline at the base of the dome, and then that pulley system up top allows them to use the custom conservatory access system, which I was not in charge of, to get up there, either to replace glass that's been damaged, to apply the shade cloth, or to remove the shade cloth. So the system is really just a way to provide a removable vertical lifeline when they do have to go up on the custom conservatory access system. And there's so much documentation. I want it, we as designers, recognize that, when the ball gets dropped, it's with the training piece. So we usually videotape the training, put it up on YouTube and give them a link. And then we have like diagrams as well as text. And I think text is the things people will kind of read last, but we have it in multiple different formats. Case study 4 is a contemporary public building on Long Island. One of those sort of famous architects that do the fancy design and then hand it off to somebody else to actually do the details. And let's see how many inaccessible smoke detectors you can see in this picture. How about this one? This is my favorite, that one, beeping right outside of the important judge's chambers. He was not obviously very happy. Another part that I love is that they have fall protection tracks, but no way to get to the fall protection tracks. So this is where, my guess, was not involved in the original construction, was that there was a manufacturer involved at some point and said, oh, we have tracks that allow you to clean skylights. So here's a drawing. So they put in the tracks and nobody knows where the shuttles are. Then there's no tagline to get yourself to the track. So it was kind of a comedy of errors. We came up with, first of all, we did a complete room by room inventory of all of these different areas and then provided sort of a range of options, which obviously for a finished building with double, triple, and quadruple height spaces was not really what they wanted to hear. So we ended up, they ended up getting a series of lifts and had to reinforce the floor to make sure that these atrium lifts could be supported by the existing floor structure. So now what? All these projects are completely different. That's kind of why I love them, because when the phone rings, there's going to be some common elements to a project you may have worked on before, but it's typically always a very interesting problem and then a kind of fun process to work with the stakeholders to give them a range of options, obviously with a range of costs associated, and then kind of follow that through to see where it goes. So the very first thing is go there with an open mind and define the problem. Talk to everybody you can talk to the maintenance workers. Don't just talk to the building owner and the architect. Make sure you're sitting down with the building engineers, the guys and girls who are actually doing the work, so you understand what their problems are, because it's not always that the architect or the building manager might not totally understand exactly where those dangers lie. And then assemble the team. And this can involve a manufacturer. I have several close colleagues that I will call upon to sort of talk through a problem. Present and discuss the potential solutions, starting with that, the hazard elimination, if at all possible. In many cases, it's not, and then go to, okay, can we do a railing? Yes, no. Can we do fall restraint? Yes, no. Okay, now we're doing fall arrest. Okay, so that's getting pretty serious. We really try to stay totally away from administrative controls because of that continuity issue. So then we designed the system after the entire group has come together and said, okay, this is the direction we're going in. Then it's typically, depending on the access, if it's scaffolded, say, it is typically the general contractor who will install the system. There are times when it's more of a specialty contractor if the access for the initial installation is challenging. And then again, harping away, train, and keep training. I always think of it, maybe I've closed that project out and sent the final invoice, but the liability of what I just designed and installed on that building is going to be with me and my professional engineering credential in that state until the day I die. So this is the part that worries me the most is, okay, well, training's not until 3 weeks. You can work for 3 weeks and then we'll train you. Well, that's when they're most exposed to not understanding how to safely use an installed system. So that is pretty much all I have, and I am happy to take questions. Okay, Michael Mazzocco says, what design load do you use for fall arrest? So it depends on many factors. So OSHA says that we have to design for a dynamic load of a 310-pound individual. It depends on what kind of system you are using. It depends on the length of the lanyard. It depends on whether you have shock absorption in that lanyard. It depends on if you are using a vertical lifeline. Is it a cable or is it a rope? Because there's also shock absorption in the elongation of a rope. So I would love to be able to just tell you that you can just spit out an answer. The one thing I will say is everyone has heard that OSHA uses 5,000 pounds for a quote unquote non-certified anchorage. So the discrete fall protection anchor or rope descent system anchor that a building has decided to install on its roof. If it's called non-certified, the language makes no sense. If you're an engineer, it can be a certified anchor. But if you're not an engineer, it has to be a 5,000 pound non-certified anchor. And so if we have zero information about that detail, we will either do probes to try to confirm what the connection is and then sort of do the engineering math about what that anchor and whether it's compliant or not. And then last case, like sort of last ditch effort to find information is we will proof load those as well. And I can send you information in a separate presentation about the current engineering consensus on proof loading existing anchors. That's all to say it's incredibly complicated. I know that's not very, I'd love to be able to just give you a load, but that's not really how it works. Okay, I will, I'll put the proof load info and give that to Sean and she can, or Judy who's helping me out, we can get that to you. Can you review further the safety features you build in at street level to protect those below? Okay, and work being done above. Okay, so this is a region to region situation. So Boston, if you're working in Boston, and you're even on a rope, you're doing RDS window washing or industrial rope access, you need a manned street closure. So you are supposed to have, there's like a bunch of off-duty police officers who are supposed to make sure that nobody passes under you. The other, if it's heavier than that, obviously if it's a swing stage, in most municipalities, you do need a sidewalk bridge. In New York, I don't remember the numbers, maybe Judy, you do, but there's some ridiculous 326 miles of sidewalk bridges in the 5 boroughs of Manhattan right now. So, and then you'll go to someplace like Philadelphia where you don't have to have a manned closure. So you just have flags and tape and signs. So you really have to understand what the local Department of Buildings requires. And it's usually sidewalks and streets are responsible for the DOT. Ooh, drones. I see more and more drones being used. Is that a technology that's working for you too? We use drones on a whole lot of our projects. The challenge is in cities can be the FAA regulatory environment. But we have, I think 5 of our employees are licensed drone pilots now. And because it was a technology that kind of went 0 to 100 in like 2 or 3 years and is still growing very fast, the FAA is getting to the point now where they're understanding that they need to turn around approvals a lot faster, and they're doing so. So there's a website called Know Before You Fly. And you can put in your address and it will show you the aviation map and you can get an idea of whether drones is a possibility or not. Have you ever hired someone who had to overcome a fear of heights, and how did that work out? That's very funny. My dad is deathly afraid of heights, actually. No, fear of heights and rope access don't really mix. I will tell you that. You know what I'll say is a healthy fear of heights. If somebody comes to us and says, hey, I just really love heights, it's like, is a thrill seeker? No, there's no thrill seeking element to our work. Obviously, our whole work is limiting liability, but that's a really funny question. No, I think it's kind of a self-selecting group who would apply to work with us. Anybody else have any questions? And I'll put I think my email, is my email up on this? Yeah, so my email is there in the bottom as well. So feel free to reach out if there's anything additional that you guys want to see. If you want a PDF of the presentation, I'm happy to provide that as well. And I think it's being recorded, but I'm not remembering if we did that or not.
Yes.
Okay. Yeah, so it's being recorded as well. So if there's anything specific that I touched on, but didn't cover in depth, just reach out. I'm happy to talk about it. I always say that I'm an accidental expert in maintenance, access, and fall protection, because it's not really why I got into rope access, but I've got all this knowledge in my head, so I'm happy to talk about it.
Yeah, Kelly, just real quick, there's one more question that just came in.
Oh, okay.
What are the professional groups that you work with to bring you into contact with colleagues?
That's a great question. So you can always be an observer at the ANSI Z359 Fall Protection Code Committee. So again, those meetings are twice a year, typically in Schaumburg, Illinois. And it's really overwhelming. You can't go to one of those and think, oh, okay, I totally understand. Everything's an abbreviation. There's so many different chapters and numbers flying around. I always know when I started going, because I have an 18-year-old who's about to go to college, and I was pregnant with her in my first meeting. So that's always a great place, because it is a combination of manufacturers, engineers, and end users. Another group, depends on exactly what you're looking for. The groups that I find most useful in this space are SPRAT, which is the Society for Professional Rope Access Technicians. That's really concentrated solely on industrial rope access. Then ANSI, and also Sealant Waterproofing Restoration Institute has a very robust safety committee, and they do a whole lot of great work about access and fall protection as well.
I'm not seeing, hold on, let me see. Okay, one more.
Every time we say that, yeah. Do regulatories understand the field and how fast it's changing? Do policies and guidelines keep up? No and no and no. The regulators, we find that, if you do have any sort of OSHA enforcement that shows up on our sites, which in 27 years has happened to me, I think twice, you have to kind of educate them on why, especially industrial rope access, is legal and safe. So a lot of it is having the appropriate paperwork, site safety plan, insurance certificates, everything on site in that project folder, so you can kind of shut down their questions right away. As far as do policies and guidelines keep up? No. Kent and I testified at the Department of Labor specifically about industrial rope access. I want to say, like, it's got to be 16 years ago now, and it took until 2019 when the walking and working surfaces revisions came out that actually mentioned rope descent systems. So no, they don't keep up. And I think there's still a whole lot of confusion out there about the differences in different types of access systems, especially because industrial rope access looks scary, and rope descent systems look scary, and it looks like you're a Yahoo, even though the safety, the training is so intense that the safety statistics are far improved over other more conventional means of access, like swing stages and scaffolds. So it's, a lot of the reason why we've got all this information is in our head is doing all this work to educate regulators and insurance brokers, frankly, about what, what rope access is and how safe it is. I wish they would keep up, but it's not the case. Don't see any other questions, but again, feel free to reach out to any of us, and happy to dig into something further if there's any additional interest.
Cool. Thank you, Kelly, so much for your knowledge and your time, and it's a very important topic, and I hope everybody enjoyed and learned a lot today. And again, this webinar is being recorded. The recording, when it's available, probably tomorrow or the day after, you will receive an email with a link to the recording, and please feel free to share with people that you think will benefit from this information. And our next webinar is scheduled for next week. Let me share my screen real quick. On July 21st, and our topic is preservation on Main Street, Charlevoix. And I hope to see you all next time. Thank you again, Kelly. Thank you so much.
Thank you.